This is page 2 for graphing rational functions. We're going to get started with example 1. And looking at this, we're going to identify the excluded value, which is going to be -3. So x cannot be -3 because that's what's going to make the denominator equal to 0. The reason we start here is because that is what gives us the vertical asymptote. So hopefully you remember from page 1, VAX equals -3 gives us the vertical asymptote. To find the horizontal asymptote, I'm going to look at this number that follows the fraction. This is what gives us the horizontal asymptote. So this will be HAY equals a -2. I'm going to graph these two right now, and you may want to pause it if I'm going too fast. So the vertical asymptote is -3. The horizontal asymptote is a y equals -2. That's actually the first step for graphing rationals. The second step is to plot a point. So I'm going to go where these two asymptotes intersect, and I'm going to go right one, up one, and plot a good point. And go back to where these asymptotes intersect, and go left one, down one, and plot a second point. And now I'm going to erase this one in the middle. That's step 2. Step 3 is we're going to take this point and extend it towards the asymptotes. And now we're actually done completing our graph for graphing this function. The domain is pretty easy to figure out. The domain comes from the vertical asymptote. So it's going to be -infinity until -3, parentheses, union, parentheses -3 to a positive infinity. We're only excluding that one number that gives us the vertical asymptote. The horizontal is what gives us the range. So we're going to have -infinity to -2, parentheses, union, -2 until positive infinity. To find the end behavior, we're going to recognize that as x approaches positive infinity, which means we're going to the right, so I'm going to follow the curve going to the right, and the y value that we're approaching is -2. Now I'm going to look to see what happens as x approaches negative infinity, meaning I'm going to the left. So I'm going to follow this curve going left, and I'm approaching the y value of, again, -2. So hopefully you guys recognize they are the same, and they're also the same as the horizontal asymptote. So let's move on to example number 2. For example number 2, the excluded value is going to be -2. So our vertical asymptote is going to be x equals -2. Following the fraction, we have the horizontal asymptote. So the horizontal asymptote is going to be a y equals +2. I'm going to graph them. So the vertical is x equals -2. The horizontal is y equals a +2. I'm going to straighten them out. Now what's different about this example from the first one is that this one has a stretch, which means that we're not going to plot one point, we're going to plot 2 points per branch. So to do so, we're going to recognize first of all that the stretch is 3. So I'm going to get started the same way I did in example 1. So I'm going to put my pencil tip or marker on the intersection of the asymptotes. Because the stretch is a 3, I'm going to go right 3. So 1, 2, 3. Well, I can't plot a point on the asymptotes, I'm going to go up 1. And I'm going up 1 because I want it in the same quadrant, if you will, as the parent function. Now I'm going to go back to where the asymptotes intersect and go up 3. 1, 2, 3. And again, I can't have a point on the asymptotes. I'm going to go right 1 to be in the same quadrant that we typically see the parent function in. Now I'm going to connect these two right now, just so you see how this looks. And I didn't do a great job, but hopefully you get the idea. Actually, there we go. Now I'm going to come back to where my asymptotes intersect, and I'm going to go left 3. 1, 2, 3. And down 1, again, to be the same quadrant as the parent function. Go back to where my asymptotes intersect and go down 3. 1, 2, 3, and left 1. to be in the same quadrant as where the parent function is. Now I'm going to connect these two towards the asymptotes. Now we don't want any of these extra points in here, so I'm going to erase them. And the curve is complete. Looking at the domain, we get it the same way as we do example 1. So the vertical asymptote gives us the domain. So the domain will be negative infinity until negative 2, union negative 2 until positive infinity. The horizontal asymptote gives us the range. So we will have a range of negative infinity until positive 2, union positive 2 until infinity. For the M behavior, as x approaches infinity, that means we go to the right, I'm going to follow the curve, and we're approaching the y value of positive 2. As x approaches negative infinity, meaning we go to the left, I'm going to follow the curve left, and we're approaching a y value, again, of positive 2. I'm going to move on now into example 3. So the excluded value for example 3 is going to be a positive 1. So x cannot be positive 1. So our vertical asymptote is going to be x equals 1. The horizontal asymptote comes from this number after the fraction. So our HA, our horizontal asymptote, is going to be y equals a negative 3. Now this graph has an extra feature, and it has this number in front. This is a reflection. So we're going to go up instead of down, and down instead of up. So I'm now going to graph my asymptotes. So I have an asymptote at x equals 1. So that's the vertical asymptote. The horizontal is going to be at y equals negative 3. Now, because of the vertical reflection that we have, instead of going up 1, right 1, I'm going to go right 1 and down 1 to plot the points. Instead of going left 1, down 1, I'm going to go left 1, up 1 to plot the point. So now we're going up and down in reverse. I'm going to extend towards the asymptotes, and extend towards the asymptotes. And then we're done. The domain comes from the vertical asymptote. So we'll have a domain from negative infinity to 1, union 1 to infinity. The range comes from the horizontal. So the range will be negative infinity until negative 3, and from negative 3 until positive infinity. For the M behavior, we look to see what happens as our graph goes to the right, and it's approaching the y value of negative 3. As x approaches negative infinity, or as we go left, the curve is approaching again negative 3. This is the end of page 2, so please continue on the third page with the third video.